Hello everyone, here is a question based on hydrogen-like atom. The number of spectral lines obtained in helium plus spectra when an electron makes transition from fifth excited state to first excited state will be how many? This question is somewhat deceiving in the sense like as if one transition is happening, but that is not true. The way we should read this question is how many transitions are actually happening between n value equal to 6 to n value equal to 2, because let's say we have several stationary states and we know that for ground state n value is equal to 1, for first excited state n value is equal to 2, and then n equal to 3, 4, 5, 6. This is the fifth excited state, isn't it? So basically electron makes a jump from here to here, but we have to calculate the in between transitions also in this case, because number of spectral lines we need to calculate. So this means, so let's say this is our lambda, then this is the largest energy gap, so therefore the lambda will be smallest here. But that is not the only transition that is happening, because we know that energy in the case of hydrogen-like atom is equal to minus Rydberg constant times z square divided by n square. Z is the value of atomic number and n is the value of the stationary state. Rydberg constant is equal to 13.6 eV. It is the energy difference that we calculate, En2 minus En1 in the case of emission spectrum. So therefore this is equal to minus Rydberg constant times z square divided by n2 square minus z square divided by n1 square. So initially the n2 value is 6 and initially the n1 value is 2. But we have to calculate the in between transitions too. So for the largest energy gap we found it, but what about the smallest energy gap? 6 to 2 transition is not the only thing that is happening here. It could be 6 to 3, it could be 6 to 4, it could be 6 to 5. All these transitions will be happening. The electron makes a jump. We would get a spectral line for these transitions too. So 5 to 2, 5 to 3 and 5 to 4, likewise 4 to 2 and 4 to 3 and then 3 to 2. These are the 10 transitions that would happen and we would get 10 spectral lines. The largest energy gap will be this one, therefore the lambda will be smallest, and the smallest energy gap will be this one, therefore the lambda will be longest wavelength will be this one, the n equal to 3 to n equal to 2. But in between we have 8 spectral lines, so that would also appear in between here, 1 2 3 4 5 6 7 8. So we would get 10 spectral lines in total. There is a formula for this. Number of spectral lines is equal to delta n times delta n plus 1 divided by 2. Delta n in this case is equal to n2 minus n1, therefore that is equal to 6 minus 2 and that is equal to 4. So therefore this is equal to 4 times 4 plus 1 5 divided by 2. So therefore 20 by 2 and that is equal to 10. So therefore 10 is the correct answer for this question.